Earth is a lonely outpost on one of the spiral arms of the Milky Way galaxy. However, there are hundreds of millions of planets in this vast whirlpool. Scientists recently discovered the first habitable zone planet the size of Earth. NASA's Exoplanet program was designed to detect unmistakable evidence of life on other worlds in the search for extraterrestrials and Earth-like planets. We've discovered some bizarre alien worlds. We will briefly discuss the host star of the planet and the newly discovered planets that resemble Earth. Consider PSRJ 1719-1438. This is probably the most amazing cosmic object you will ever learn about. First, you should know that 1438 is actually a neutron star, small but extremely dense stellar objects, with a diameter of no more than 12 miles. Neutron stars have such dense material that a teaspoon of it would weigh 1 billion tons. It is also a pulsar. A pulsar is a neutron star that emits powerful beams of electromagnetic energy from its magnetic poles. The magnetic field around the polar region measures about 1 trillion times stronger than Earth's. The rotational speed of some pulsars is incredibly fast, but the spin period for 1438 5.4 milliseconds is measured in milliseconds. That equates to about 10,000 rotations a minute. We're not talking about Earths, but exoplanets. So, the companion of the neutron star is the most interesting feature. The gas giant Jupiter is about the same mass as 1438b. However, it's only 40% the size. What happened to make this planet so dense yet small? Scientists think that 1438b was a remnant from a star whose outer layer had been stripped by the magnetic field of the pulsar. The planet is composed of crystalline carbon and has a density higher than that of diamonds. HD 189733b, first discovered in 2005, is another incredibly mysterious world orbiting only 63 light-years away from Earth. The planet's blue hue is not due to a reflection from an ocean, like Earth. Instead, it comes from a hazy atmosphere with clouds that are laced with silicate particles. These gas giants have daytime temperatures up to 2000 degrees Fahrenheit and winds of 4,250 miles per hour. It is believed that under these conditions, it could rain sideways with liquid glass. The planet is just 2.9 million miles from its parent star. It's so close, it is gravitationally bound to the star on one side. For comparison, Mercury, our closest planet in the solar system to the Sun, is 29 million miles away. Discovered in 1999, the next object is named after the planetesimal small telescope that found it. TRAPPIST-1 is a red dwarf ultra-cool star, slightly larger than Jupiter but much more massive. It is about 39.6 light-years from the Sun. NASA discovered Kepler-186f in 2014 as the first planet with a similar radius to Earth. This discovery confirmed the existence of Earth-sized planets in the habitable zone of other stars and brought us closer to discovering a world similar to ours. Astronomers used NASA's Spitzer Space Telescope and ground-based telescopes in 2015 to find not one, but 7 terrestrial planets with temperatures similar to Earth orbiting the red dwarf. These Earth-like alien worlds have a lot of rocky terrain and can hold up to 250 times as much water as Earth. The 6 planets are so close that, if you were standing on one of them, you would be able to see their moons. The red dwarf star only emits 0.5% of our Sun's energy. The planets are cold and dark, and the star has an estimated age between 5.4 billion and 9.8 billion years. Every year, more planets are discovered. In early 2020, NASA discovered a planet that was the same size as Earth and the same distance away from its star, at 13,000 light-years. The planet was discovered using the microlensing method. It is extremely cold and likely harbors no life. The ice-covered planet is too far from its star, which some scientists now say may not even be a star but rather a brown dwarf. Titan, the second largest natural satellite after Jupiter's moon Ganymede, is the solar system's second largest moon. Titan is unique. It is the only known body in outer space, other than Earth, that has stable bodies of surface liquid. Titan is similar to the Moon in composition, but is about 80% larger and 50% more massive. Titan has oceans and large lakes, but it's not what you might imagine on Earth. It's much more bizarre. In a moment, we'll discuss that. Titan has mountains, valleys, and ridges. Some of these features are deep lakes covered with ice from winter storms. So how does Titan have liquid surfaces, rain, and ice, just as Earth does? Titan's surface temperature is to 90 degrees Fahrenheit, 179 degrees Celsius. Titan's atmosphere, which is primarily composed of nitrogen 98% and methane 2%, has seas and lakes made up of liquid ethane and methane. Although these are not water, ethane and methane behave like liquid water at these extreme temperatures. Titan has some internal heat, and it may have a so-called home-baked atmosphere. This means that the warm core of the Moon is likely cooking organic molecules, and radioactive decay may be warming the Moon from the inside. Given all these factors, could Titan possibly harbor some exotic life forms? Scientists believe Titan's atmosphere is the ideal laboratory to study the organic chemistry that preceded life and provided the building blocks for life on Earth. Some parts of Titan have organic deposits, indicating that the giant moon may host biologically interesting compounds like amino acids. Titan is viewed by some scientists as a primitive version of Earth, while others say that it resembles a prebiotic Earth. Before life developed and changed our planet irrevocably, it was similar to Titan. Titan's ocean is located below a thick layer of ice and has favorable conditions for life. Tardigrades are among the few life forms that we know can survive in space and even at temperatures of 328 Fahrenheit. They can also withstand temperatures of up to 300 Fahrenheit. They can endure radiation and boiling liquids, as well as immense pressures up to 6 times the pressure in the deepest part of the ocean. It's impossible to determine what type of life might exist on Titan, given its extreme conditions. Some astrobiologists argue that Titan's lack of liquid water suggests there's likely no life on its surface. If life exists on Titan, could it thrive in Titan's methane oceans? Scientists agree that if there are organisms, they would be microbes, either small or single-celled. NASA believes there is enough evidence to suggest potential life on this moon and plans to land a flying robot on its surface. The Cassini mission, well known to most, has already taken us to Titan. Many people don't know that on January 14, 2005, Cassini launched a small probe named Huygens. It made an amazing film during its 2.5-hour descent. Huygens landed in a field of rounded blocks of ice, surrounded by dry shorelines and rivers of methane. Dragonfly is the name of this new mission, which is a pioneering endeavor. The quadcopter, the size of a car, is equipped with instruments that can identify large organic molecules. The Dragonfly is planned to launch in 2026 and reach Titan by 2034. It will land near Titan's equator among solid hydrocarbon snowflakes. The vehicle will be powered by heat generated by radioactive plutonium, similar to NASA's Mars rover. Its 8 rotors will enable it to travel much further than any wheeled robotic vehicle has. The Dragonfly will need to be able to navigate autonomously, as it takes 43 minutes for light signals to travel from Earth to Titan, making Dragonfly harder to operate than conventional drones. The drone will have a navigation system specifically designed to help it identify and avoid hazards. It will also be able to land itself. Dragonfly's air sampling will be highly sophisticated. The craft will sample the atmosphere while in flight and provide aerial images of the terrain. It will then fly to multiple locations, hundreds of miles apart, and collect data. The ultimate destination will be Selk Crater. This is the site of a meteor impact that occurred thousands of years ago. Scientists have found evidence of liquid water, organic molecules, and energy sources that could fuel chemical reactions. The NASA Frontiers program will fund this mission, the 4th in a series of missions that support medium-sized planetary projects with a budget of less than $1 billion. Dragonfly is projected to cost $850 million at launch. Titan's future could turn warmer when the Sun transforms into a red giant in 5 billion years, starting the process of helium fusion. Mercury, Venus, and Earth will be engulfed by the outer layers of our star as it expands. This solar transformation could provide a glimmer of hope for other moons and planets, like Titan. Titan's surface temperatures could rise to 94 degrees Fahrenheit. This is high enough to allow stable oceans of ammonia and water to exist as the Sun's ultraviolet output decreases. Titan's upper atmospheric haze would also reduce, permitting the greenhouse effect caused by methane to take over. Together, these conditions could create an environment that is favorable to exotic life forms and could last for several 100 million years. This duration was sufficient for life to evolve on Earth. NASA's Transiting Exoplanets Survey satellite, TESS, discovered an Earth-like planet named TOI 700d at the beginning of 2020. It is among only a few known to potentially have the right conditions for liquid water on its surface. The exact condition of the planet is not known until further measurements are taken. The James Webb Space Telescope holds the key. This telescope, set to launch on March 30, 2021, will provide infrared resolution far superior to the Hubble telescope. It costs $10 billion, making it one of the most sophisticated telescopes ever constructed. Its mirrors, coated with pure gold, are exceptionally pricey. The James Webb Space Telescope can image the farthest events and objects in the universe, such as the formation of the first galaxies. It is believed that this telescope might aid in discovering a planet similar to Earth, teeming with life. We have yet to find anything similar in the universe. Super-Earths exist, and there is a good chance that we will find planets with more favorable conditions for life than on Earth. The search for liquid water is ongoing, because where there is water, there is potential for life. The new telescope was launched on October 31, 2021. It is filled with incredible technology that can finally answer the question: is the Earth unique, or is there another, better planet? Could there be another planet, another Earth, more hospitable than ours? Earth, the only planet we know of that has huge liquid bodies covering more than 70% of its surface, may soon find company in space. Mars and other inner planets might have had liquid water early in their existence, allowing life to develop before they turned into the harsh, barren worlds we know today. Finding liquid water on an Earth-like exoplanet or super-Earth, however, is only the start of our quest. Our chances of discovering life increase if we find liquid water on the surface of a planet. All living things require water to survive. Chemical reactions are the basis of almost all processes that make up earthly life. These chemical reactions require liquids to break down substances. In fact, water is one of the most common molecules in the universe, according to observations from space and on the ground. The Japanese spacecraft Exoplanets has recently returned samples of an asteroid with water and organic materials. It was amazing to find that the asteroid did not pick up water from anywhere. The source is unknown. This could mean that there are many super-Earths with liquid water waiting to be found. You can watch a video of the Exoplanets mission if you wish, but it must meet certain criteria. This planet must be at a certain distance away from its host star. If it is too close, the water on the planet would freeze and become unusable. If a planet were too close to its star, it would all burn up, including oceans and atmospheres. Scientists from NASA recently stated that exoplanets could have oceans in the Milky Way galaxy. With the technology that we currently have, it is not possible to detect liquid on an exoplanet's surface. However, there is a way of looking at the atmosphere of a planet and detecting water vapor. If there is water vapor, it could be evaporating from the ground or from vast oceans. The Kepler Space Telescope discovered an exoplanet called K218b in 2015. It is the size of 8 Earth masses and orbits a star that is 124 light-years away. The pressure is intense on this planet, not its gravity. In 2017, data from the Spitzer Space Telescope confirmed that this super-Earth is orbiting its star in the habitable zone and takes only 3 days to complete its orbit. NASA's best candidate for a habitable world is K218b. In 2019, 2 independent research studies combined data from the Kepler, Spitzer Space Telescope, and Hubble, and found a surprising quantity of water vapor within the atmosphere of the planet. Researchers used the data to examine the spectrum of light passing through the atmosphere of the planet during transit, or when it passed in front of its host star. The hydrogen-helium atmosphere of K218b has a water concentration between 20% to 50%. Even the idea that this planet might have rain clouds has been suggested. The radiation that K218b receives from its star is similar to what the Earth gets from the Sun. If we could travel faster, would we be able to live on K218b? Some researchers claim that the planet's atmosphere is so thick and dense that it could prevent life from existing. This is because the majority of the planet's surface is covered by a massive gas envelope. It's likely that there is a rocky core surrounded by an enormous hydrogen envelope with some water vapor. Landing on this planet is nearly impossible since the gas is thick and has high pressure. Any Earth-made spacecraft would be crushed, squeezed, or destroyed by the pressure. TRAPPIST-1 was discovered in 1999. It is a red dwarf ultra-cool star that has a radius a little larger than Jupiter. It lies 39.46 light-years from Earth. NASA revealed on February 22, 2017, that 7 rocky planets the size of Earth orbited the star. Each of these planets has the potential to have water on its surface. A year later, in February 2018. These 7 planets may have more water on them than the oceans on Earth, according to a closer examination. 3 of these planets have the perfect distance from their star to be warm and liquid enough. The Hubble Space Telescope found that TRAPPIST-B and C are unlikely to have hydrogen-dominated atmospheres as gas giants. It is a very strong argument. Both planets may be rocky, and they could possibly contain water. Both TRAPPIST-B and C, as well as TRAPPIST-1, have thick, hot atmospheres that are similar to the planet Venus. These exoplanets, unlike Venus, are too hot for sulfuric acid to form. Both planets may be so hot that their surfaces are covered with molten lava. TRAPPIST-E is the smallest planet in the solar system. It is likely to have a hydrogen poo atmosphere similar to Venus, Earth, and Mars. It is half as massive as Earth and receives about 4.3% more sunlight than Earth from the star. It also lies at the outer edge of the habitable zone. This planet may have oceans or layers of ice. A new study suggests that the atmosphere of this planet is more like Venus's uninhabitable one. TRAPPIST-1a is an exoplanet that orbits the habitable zone. It is similar in mass, gravity, and temperature to Earth. Astronomers claim it has a dense atmosphere, and that this planet has the best chance to be an ocean world like Earth. This planet has the potential to be habitable for life as we currently know it. TRAPPIST-1f is probably a world similar to ours, but under a massive envelope of water vapor, gaseous at high temperatures and pressure. This planet may have a liquid ocean covered with an atmosphere rich in oxygen. However, this exoplanet is likely to be no more habitable than any other gas giant or ice planet with water clouds in its atmosphere. TRAPPIST-1 may also have a thick ocean of water on the surface, covered by an atmospheric layer containing hundreds of bars of abiotic oxygen. It has temperatures of around -155°F, similar to Earth's South Pole, and is likely covered with ice. Scientists say that it may hold liquid water. The TRAPPIST-1 planets are likely to be tidally locked, which means that they could all have zones that are warm enough for liquid water and don't get bombarded by radiation from their star. We may soon find out if one of these exoplanets is a super-Earth with liquid water and possibly even life. On Halloween, October 31, 2021, the James Webb Telescope, a triumph of space science and perhaps the most famous unmanned satellite since Sputnik, will be launched. The planets of the TRAPPIST-1 system will be the first planets that it observes, as its main objective is to make the first detailed study of an atmosphere orbiting a planet in the habitable zone. The James Webb Space Telescope's special near-infrared spectrograph, also known as a spectrometer, will be used to find signs of an atmosphere. It disperses the light from an astronomical object, such as a star, into a spectrum. Analyzing the spectrum can reveal information about the physical properties of an object, including its temperature, mass, and chemical composition. On inspection, atoms and molecules leave a unique fingerprint for each chemical element, which can tell us even more about the physical conditions in the object. It is exciting to know that the Webb will be able to see oxygen in the alien atmospheres of planets around other stars. At least 4,000 exoplanets have been discovered so far, and many of them orbit in the habitable zones. Our atmosphere is filled with oxygen because of the presence of algae, plants, and bacteria. This is a much higher amount than if our planet were devoid of life. Understanding Earth's atmosphere helps us know what to look for. Researchers hope to detect oxygen molecules colliding in the atmospheres of distant planets using the James Webb Space Telescope and a new technique created at the University of California, Riverside. When oxygen molecules collide, they block a portion of the infrared light that is normally visible to telescopes. The James Webb Telescope will be able to send back data to researchers that they can use to determine the chemical composition of an alien atmosphere. The Webb will look at water worlds, some of which may get too close to a star or heat up from a runaway greenhouse effect, similar to what happened to Venus. They can also lose their oceans into space. Radiation breaks down the water molecules into hydrogen and oxygen. Since hydrogen is the lightest, it quickly floats into space, leaving behind oxygen. The presence of oxygen in the atmosphere of a planet is exciting because it has a connection to life. However, we don't yet know if oxygen is produced in the atmosphere only by life. The advanced technology will enable us to detect oxygen on planets that are either alive or dead. It looks like mankind will find life on other planets. It's just that we haven't had the technology until now to detect it. What are you looking forward to seeing with the James Webb Space Telescope? Do you think there's life on other planets? Let us know what you think. Stay tuned as things change quickly. Scientists have found exoplanets that could potentially be habitable for a long time. There are hundreds and millions of them, with more being discovered every day. We don't know of any planets like ours in the universe. Scientists say that they've found exoplanets that could be more habitable. Do they exist? Any world that orbits another star other than our own solar system? The size of exoplanets ranges from giant gas planets like Jupiter to smaller rocky worlds like Mars or Earth. The majority of planets discovered are located in a small area of the Milky Way galaxy. We know that NASA's Kepler Space Telescope has observed more planets than stars. Since 1990, we have discovered thousands of exoplanets using different methods. It's not easy to find them. At least 300 million exoplanets could be habitable in the Milky Way galaxy. Kepler, the US space agency's space telescope that spent 9 years on a mission to find exoplanets, identified thousands in our galaxy. It ran out of fuel in 2018 and had to be retired. Kepler analyzed all of the data and found that 300 million rocky worlds may be capable of supporting liquid water on their surfaces. However, this is only a rough estimation because the Milky Way contains between 100 and 400 billion stars, and each of these stars likely hosts at least one planet. There are probably trillions of them. It may seem easy to use a telescope to locate them, but you're unlikely to be able to view an exoplanet from Earth in the same way that Saturn is visible. Direct imaging is the method used to find exoplanets, but the transit method is used to find most exoplanets. It measures the dimming of a star when a planet passes in front of it. Exoplanets can also be detected using gravitational lenses or by measuring the star's light spectrum to look for signs that a planet is gravitationally affecting it. By combining all these methods, we can find more exoplanets in the vast universe. If we want to find exoplanets capable of supporting life, we should first look for planets orbiting their host stars within the habitable zone. The habitable zone is the region around a star that is neither too hot nor too cold to support liquid water. The planet must also be the correct size and orbit a star of a specific type. Our own yellow dwarf sun has been stable for more than 4.5 billion years. But this is not the case with all stars. Now, let's discuss different types of stars. Proxima b was first detected in 2016 by the Hopps telescope. It is located 4.2 light-years away from Earth and is in the habitable region of its red dwarf star, Proxima Centauri. A new telescope called Espresso discovered that Proxima b is only 17% larger than Earth, making it more Earth-like and more likely to have life than previously thought. Scientists believe the planet was habitable because it is at the perfect distance from its star for liquid water. Future generations of superfast spacecraft could visit the planet to search for life. However, in the same year, a huge solar flare was emitted from the red dwarf Proxima Centauri. It was 1,000 times brighter than the star itself. The ultraviolet radiation that hit Proxima b was 4,000 times higher than what Earth receives from a solar storm from our Sun. Researchers believe this could have destroyed all life on the planet. Proxima b, however, is not the only candidate for a habitable world. Scientists say they have discovered 24 superhabitable planets, or exomoons, that may be more suitable for the evolution and emergence of life. Two researchers came up with the concept of superhabitable in 2014. Renee Heller, John Armstrong, and others have said that an exoplanet must be more than just in the habitable zone to be habitable. A planet that is more suitable for our way of life would be one that is older, bigger, warmer, wetter, and has a higher level of oxygen. It could also have a star with a longer lifespan. Heller and Armstrong proposed that a super-Earth should be at least 2 Earth masses in size because the radioactive decay inside the planet would provide more heat. The stronger gravity would also hold the atmosphere for longer. The 24 superhabitable planets were selected because they are in the habitable zones and have stars of the correct size, lifespan, and orbit. These exoplanets orbit G-dwarf stars that are similar to the Sun. Researchers also searched for exoplanets that orbit K-dwarf stars, which are cooler, smaller, and less luminous. There are also 50% more orange dwarfs than yellow dwarfs in the Milky Way. These Sun-like stars may not seem ideal for life, but they do have an advantage. They can live anywhere between 17 billion and 70 billion years, compared to our Sun's 10 billion year lifespan. If life began on a planet that orbited a K-star, it would have had more time to develop than life on Earth has had. Consider that complex life evolved on Earth in 3.5 billion years, while advanced life like humans took 4 billion years. Exoplanets with larger sizes could have more land mass for habitats and more space. These superhabitable planets would have heavier gravity and a thicker atmosphere, allowing organisms to spread life through the air. Scientists say the sweet spot age for a superhabitable exoplanet ranges from 5 to 8 billion years. Since we understand that there is more diversity of life in warmer and wetter climates, some of these more habitable planets could resemble Earth during the early Carboniferous period about 359 million years ago, when it had a tropical rainforest climate. We know that warmer climates and more moisture are conducive to more diverse life. Some of these habitable planets may resemble Earth during the early Carboniferous period, 359 million years ago. The planet then had a climate similar to a tropical rainforest. Gliese 667 cc orbits the red dwarf star of the Gliese 667 system. Yes, 3 stars. That's what you'd see if you were standing on Gliese 667 cc. Gliese 667 cc is 23.62 light-years from Earth and has a minimum mass of 3.7 Earth masses. Kepler 452b, also known as Earth 2.0 by some, is another superhabitable world. It orbits a G-type star similar to the Sun but 1.5 billion years older. Others speculate that an ancient civilization could have existed on the exoplanet or its moon. It's possible we are now seeing a preview of Earth's future because the star it orbits has used up all its fuel and expanded into a giant red. There are also other things we should look for. There is currently no way of detecting oxygen in the atmosphere of an exoplanet. However, soon things will be different. The James Webb Space Telescope will be launched into orbit on October 31, 2021, by an Ariane 5 rocket. The telescope's technology is unique, and it is the successor of the Hubble Space Telescope. It will be an important new tool for the study and search for exoplanets with the potential to support life. The James Webb Telescope is set to orbit the Sun at a distance of 940,000 miles from Earth. It will be the largest telescope ever launched into orbit and will utilize cutting-edge optical science and engineering to explore uncharted territories. Researchers have developed a new method that will enable the James Webb Telescope to detect a unique signature produced when oxygen molecules collide. If such a signal is found, it would indicate the presence of oxygen on the surface of an exoplanet. However, the Webb telescope will only be able to detect oxygen signals on a planet orbiting a red dwarf star if it is within 16 light-years of Earth. The James Webb Telescope is primarily designed to study the evolution of the solar system, the Big Bang, the first glow from the Big Bang, and distant exoplanets. To see farther into space, we may need an even more powerful telescope. the Nancy Grace Roman telescope, set to launch in the late 2020s, will have a viewing area 100 times larger than the Hubble Space Telescope. It will extensively explore dark matter and dark energy, the mysterious and mostly unknown phenomena that make up the majority of our universe. Additionally, it will be capable of capturing direct images of exoplanets, something that is not possible from Earth. However, its main mission objective is to peer deep into the Milky Way galaxy using gravitational lensing to discover thousands of exoplanets. We are entering an incredibly exciting time in human technology, and with the vast number of habitable worlds out there, it is highly likely that we will finally discover life on a distant planet. The increasing number of habitable planets opens up a thrilling chapter in human history, where the existence of life on a far-off world becomes a real possibility. The Kepler telescope was specifically designed to search for exoplanets in a specific patch of the Milky Way. The exoplanet hunters observed hundreds of thousands of stars during its mission and discovered thousands of exoplanets. In 2009, NASA launched the Delta II rocket as part of its Discovery program, carrying the Kepler telescope. Kepler's mission was to continuously scan a fixed patch of the Milky Way galaxy in search of planetary systems. Equipped with the largest primary reflector ever launched into space and a 96-megapixel camera for light processing, Kepler aimed to determine how many stars had planets orbiting them and how many of these exoplanets could potentially support life. During its 9-year stay in space, Kepler confirmed the existence of 2,662 exoplanets and observed 530,536 stars. These exoplanets had never been seen before in our own solar system. Many of them orbit so close to their stars that they complete a revolution in just a few days. Some of these worlds have unique characteristics, such as extreme temperatures high enough to melt iron or hemispheres with oceans of molten rock. There are even planets as large as Jupiter that orbit two stars, offering the spectacular sight of binary sunsets from their surfaces. Kepler's most significant contributions were the discovery of Earth-sized planets that orbit within a safe range from their stars, known as the habitable zone or Goldilocks zone. This zone provides the right temperature for water to condense on the surface, enabling the possibility of liquid water, a crucial ingredient for life. Water serves as the foundation for all life as we know it. One of the exoplanets discovered by Kepler that has caused excitement among scientists is K2-18b. In September 2019, two scientific teams independently announced the detection of signs indicating the presence of liquid water in the atmosphere of this planet located 124 light-years away from Earth. K2-18b is approximately 8 times more massive than Earth and 3 times larger in size. It orbits K2-18, a red dwarf main sequence star. According to Kepler, red dwarf stars are the most prevalent type of stars within the Milky Way galaxy, with astronomers estimating that 6% of the red dwarfs in our vicinity have an Earth-sized planet. Discovering water on these planets is a significant breakthrough in the quest to find alien worlds that could support life. K2-18b was the first exoplanet detected by Kepler to have water, with its discovery dating back to 2015. Since then, its composition has been further studied by other telescopes such as Hubble and Spitzer. Kepler employed the transit method to search for exoplanets, which essentially involves measuring the slight dimming of a star's light when a planet passes in front of it. This is how we know that there is a planet present. The amount and duration of the dimming provide valuable information about the planet's size and orbit. Detecting the transit of an extraterrestrial planet is challenging, since Earth's diameter is only about 1/109 that of the Sun. If an observer from outside the solar system were to witness Earth's passage, it would cause a mere 0.008% dimming of the Sun's output. Kepler's cameras were indeed sensitive enough in 2014 to detect such a slight change in luminosity. Kepler's discovery of Kepler-186f, a potentially habitable planet in outer space, sparked the imagination and curiosity of space enthusiasts when NASA first announced its existence. A recent study from Georgia Tech University suggests that this exoplanet, located 500 light-years from Earth, may have similar seasons and climate as Earth. Analyzing the planet's spin and axial angle, researchers found its tilt to be stable, resembling Earth's tilt. This indicates that Kepler-186f likely experiences seasons and a climate similar to our own. Similar research on the Kepler database is being conducted in research universities worldwide. In recent years, previously rejected Kepler discoveries due to algorithmic errors are being revisited as potential Earth-sized exoplanets. These false positives are now being reanalyzed using data from other telescopes. Kepler-1649c is one such planet. It was discovered in mid-2020 by combining old Kepler data with new data from the TESS mission. Astronomers have confirmed that Kepler-1649c has very favorable conditions for life. Located 300 light-years away from Earth, this newly discovered world is similar in size and temperature to Earth. It is about 1.0 times smaller than Earth and receives approximately 75% of the starlight that Earth receives from its host, a red dwarf star. This suggests that the exoplanet's temperature may be comparable to Earth's. Kepler-1649c is another example of an Earth-sized planet found in the habitable zone of a red dwarf star. However, it's important to note that out of the 2,662 exoplanets discovered by Kepler, only 16 are located within the Goldilocks zone. Some of these planets are tidally locked, meaning only one side perpetually faces their parent stars. This configuration is not ideal for supporting life. Other exoplanets in the Goldilocks zone can be smaller versions of Neptune or larger versions of Earth. Planets like Neptune may have a thick hydrogen envelope surrounding any water layer on their surface. If the hydrogen envelope is too thick on a planet with a core of iron and rock, the pressure and temperature beneath the surface would be too high to sustain life. Red dwarf stars, despite being cooler, are more active than our Sun. Planets orbiting these stars may experience higher levels of damaging ultraviolet radiation compared to what we are accustomed to on Earth. Surface temperatures on these exoplanets can vary between 100 to 116 degrees Fahrenheit 73 to 47 degrees Celsius, making the average surface temperature colder or hotter than Antarctica. Answering these questions requires technology that we don't currently possess. However, statistical analysis of Kepler observations suggests that approximately 1 in 5 Sun-like stars may have Earth-sized planets within their habitable zones, with temperatures conducive to supporting life. Considering that about 20% of the stars in our Milky Way galaxy are similar to the Sun, there could be several billion potentially habitable, Earth-like planets just within our own galaxy. Kepler's efforts were not limited to finding habitable planets. Kepler's discoveries included fascinating but inhospitable worlds, such as gas giant planets composed mainly of hydrogen and helium with a small rocky core, commonly known as hot Jupiters. These planets orbit extremely close to their parent stars and are abundant in Kepler's findings. One intriguing example is Koi-5ab, a gaseous giant planet. Astronomers initially identified it as a possible planet in 2009, but its discovery was missed a decade earlier due to the vast amount of data generated by Kepler. Additionally, the presence of another star accompanying the main star in the Koi-5 system complicated the analysis. It was later revealed that the Koi-5 system actually contains 3 stars, further increasing its complexity. Satellite scientists confirmed the existence of the Koi-5AB planetary body within a multi-star system, thanks to additional data collected from the mission. This rare discovery is expected to contribute significantly to our understanding of planetary formation. Kepler also identified super-Earths, which are more massive than Earth but lighter than ice giants like Neptune or Uranus. These planets can be composed of gas, rock, or a combination of both. Jacksonian planets are the cause of hot Jupiters that have vaporized, and Trojan planets are also part of Kepler's intriguing findings. Kepler was finally retired on October 30, 2018, as it ran out of fuel. The telescope was deactivated with a goodnight command from Mission Control the following month. Although no longer operational, Kepler's incredible discoveries paved the way for future advancements in astronomy, where advanced telescopes both on Earth and in space will help unravel the mysteries of the objects Kepler observed. In 2021, the James Webb Telescope is scheduled to be launched into space, and it will provide a closer look at these Kepler objects, bringing us closer to answering the profound question: are we alone in the universe? What are your thoughts on these discoveries? Kepler's data has revealed many other fascinating worlds,